can actually see what we're doing. Okay. All right. So in cell A1, we're going to start, we're just going to write variables. Spell it correctly. And then we're going to have our coefficients. And finally, the values. Okay. Variables, coefficients, and values. And to identify them, I'm going to come over, pick one of these cell styles here, like the heading 1 or 2, whatever. The one I'm going to pick is accent 1, blue. We're going to come down, we're going to need some space here because we're going to have 1, 2, 3, 4, 5 constraints and 1, 2, 3 variables. It looks like we have an x1 and an x2. So we're going to have an x1 variable and an x2 variable. The coefficients for these variables are going to go here. All right. So to start, we're going to have a 5 and a 7. We get $5 off of the x1, $7 off the x2. So the coefficients for those would be 5 and 7. And right now, the values are 0. We don't know what they are, okay? So we have 5 and 7, and then zeros for those, okay? We'll come down to A6, and we'll write objective. The objective is to maximize our profit. So we're going to max, and then we'll do the sum product of those, because if we multiplied 5 by x1 plus 7 by x2, then wrote out the answer, that would be the sum product of these together. So we're going to say equals sum product of the coefficients and the values. Okay. So then our formula is the sum product of the coefficients and the values. The next thing we need to do is account for our constraints. And so on the constraints, right, we're going to have a left-hand side, and this is where we're looking at the subject to part. The constraints are the subject to part. So each of them is represented as an inequality. You have the left-hand side of the inequality and the right-hand side of the inequality. And so we're going to set that up as the LHS, then the inequality, and the RHS for right-hand side. So in this particular instance, we have 5 constraints. There's the x1 less than or equal to 6, 2x1 plus 3x2 less than or equal to 18, x1 plus x2 less than or equal to 8. And then we have the 2 non-negative constraints. So we put in 1, 2, 3, 4, 5. All right. And so here, I'm just going to go down and I'm going to put in each of the left-hand sides. So for the left-hand side, we grab the value of the piece. So we say this is going to equal to whatever the value for x1 is, because it's the x1 variable. Okay, and that's going to be less than or equal to 6. For the next one, we're going to multiply this out, and it's going to be equal to 2 times x1 plus 3 times x2, and that's going to be less than or equal to 18. For the next one, it's just going to be x1 plus x2, so it's going to be equal to x1 plus x2 less than or equal to 8. And then the next two are just going to be the greater than. Okay? So we're going to say equals x1 greater than or equal to 0, and then equals x2 greater than or equal to 0. All right? So now we double check each one of them. So this one corresponds to the blue one. This corresponds to the red constraint. This corresponds to that green constraint. So here's where each one of them come from. My profit maximization is here, where we have the sum product of 5 times x1 plus 7 times x2. So let me stop here and ask, does anyone have any questions? Okay.
Did you
So
put the values
Jared,
for
just
3?
hang on, Andy.
Sorry.
Jared, just to remind you, I am recording this, so if you didn't catch it from the beginning, that's okay. All right, Andy, what was your question?
For the left-hand side, did you put the values or the coefficient?
The values.
Okay, cool.
So for the first one, it's x1 value, and we set it equal to 0 in the beginning. So for instance, if I were to sell one x1 and one x2, then I should make $12. Is that correct? Right, so we got a 1 and a 1, so I get $12. And I set it equal to the value so that each of these will be will correspond to whatever comes up here. Okay, so I'm going to go ahead and change that to dollars as well. All right, now Uloma, you remember from the last time, if you could recall, when we have done this correctly, how much profit should we have made? What is the target that we should be looking for here? Do you remember that? $44. That's exactly right. So if we got this right, now where she's getting that is from the original project that we did when we did the graphical method. So if we got this right, then we know that $44 should be our target. Okay? Got it? Okay.
Yeah.
All right. So for those of you who are coming in late, remember that I'm recording this, right? And so we'll be able to make sure that we're all on the same page. And you'll catch up when you do the next lab. Okay, so the next thing we want to do is we need to go to data, and you're going to use the solver. Now let's stop right here and make sure that everybody has the solver. I need you to either say yes or give me a thumbs up if you have opened up your computer and you have the solver next to the data analysis tool pack. If you don't, let me know. Okay. So here's how you install that. So the two people who have told me that they don't, right? The rest of you aren't paying attention, I guess. Jordan, do you have this? Jared, do
No.
you have this? Okay.
So I was pulling it up to see if I had it or not.
It's okay. All right, so everyone who's told me they don't have this has a Mac. So let me show you how to do that. Okay. And Jared, yes, of course I am. Okay, so you're going to go to Tools, Excel Add-ins, and check the box that says Solver Add-in. So you should have the Analysis Tool Pack and the Solver add-in checked. Okay. When you click OK, you should now have that solver over there. All right, so we all got it now? We good?
Yeah.
Okay, Anya's good. Andy's good. Loma, you good?
Yeah.
I got
George, you
it.
good? Okay. Jared, you good? You got that solver? Okay. Okay, so now that we have that, we're going to use the solver to do some rather complex mathematics for us. Okay. So what we want to do, our objective is where we put the objective function. So we're going to highlight here and we're going to select where that objective function is. Right? Now let me close this out and let me point out that the formula we're looking for is the equal sum product. So you need to have a formula there and not just numbers, all right? So hopefully you've got that in there. So you're going to click here, click the solver, and our objective function is in C6. We want to maximize that by changing the only thing that we can change, which is here. We're not going to be able to change our prices. We're not going to be able to change our constraints in the short run. The only thing we can do is change the number that we sell. Okay? So then we want to add each of our constraints. We're going to end up adding 5 of them here. So we're going to add, okay, cell reference here. It says less than or equal to, and we want the cell reference to be 6. Do not type in 6, actually put in the cell reference. Then we're going to add another one. We're going to add the second one, which is less than or equal to 18. Add a third one, less than or equal to 8. And then for the next two, we're going to change it. It's going to be greater than, okay, or equal to the 0. Add a third one. Zero. Okay. We click OK, and what we end up with are these solver parameters. So we double check them. We want to set our objective C6 to the max by changing the values here subject to the constraints that we have outlined here. Okay. Now, check the box that says unconstrained variables need to be non-negative. That means you can't go into the third quadrant where they're both negative. For the solving method, we're going to pull that down and we're going to pick the one that says simplex LP. Okay. So that makes them straight lines and makes them easier for us to understand. Okay. There are other methods, but this is because we all have linear equations, we're going to use this one. Okay. Now, when you click solve, right, you're going to come up with some answers. So this is the solution. So it says solver found a solution. All the constraints are optimal and optimality conditions are satisfied. Now, I know I got it right because when we did the linear programming, we did the graphical method. We said our target was 44. My objective function has been maximized to 44. We also know that when we did it, we were able to do this by selling 6 of the X1s and 2 of the X2s. Okay. We're going to look at the answer, sensitivity, and limits as well. Okay. All right. We click OK. All right. Now it's produced for me. Sheet 1 was where I solved it. I have an answer report, a sensitivity report, and a limits report. So for the answer report, okay, we have this particular answer. So we look and we see on our objective function where we maximize the value, we find a final value of 44. Okay. We also see that the final value for that was to produce 6 X1s and 2 X2s. And we also find which of our constraints are binding. So when you have a slack of 0, that means it's a binding constraint. Okay. So I'm going to ask you in the problem to tell me what is my optimal solution. And the optimal solution here would be to produce 6 of the X1s, 2 of the X2s. I'm going to ask you what is the binding constraints, and you would tell me that constraint 1, 2, and 5 are the binding constraints. So far, so good? Okay. Let's come over here to our sensitivity report and take a look at that. Right? Okay. So this tells me, again, what is my final value? What was the objective coefficient? What was the allowable increase and decrease? The allowable increase and decrease are the bounds between which you can change those values and the optimal solution will still hold. So the allowable increase and decrease are the bounds around which, or excuse me, you can still same okay. So that's a good way to put that. Let me come over where you can see that. Okay. What the heck's up with this? There we go. Okay. For our shadow price, I think I told you this in the previous video, but just for the shadow price, this is how much you would be willing to pay for an additional unit of that resource. So for resource number 1 or constraint number 1, if we could get more of it, we would be willing to pay $2 extra for that. How much more would you pay for this? $1. So again, shadow price, right? It's also known, the shadow price is also known as the marginal utility, okay? Shadow price and marginal utility are the same thing. Got it? Let's take a look at our limits report here. All right, so on the limits report, this is telling me what the bounds are, okay? It tells me how much we're going to spend to make that much money. So in order to make $44, we're going to spend 85 and 110. Our upper limits and our lower limits are here. If we don't make them, this is still what we have to spend. If we do make them, this is what we would end up with. So there's not a lot of information on here. Let's go over to, so here. Let's come back over here for just a moment, okay, and talk about this concept of reduced cost. Reduced cost is also known as the opportunity cost, okay? So let me go over here and adjust this. All right, and then we will talk about reduced cost, all right? So if we were unable to find an optimal solution, that reduced cost would be greater than 0. It would be a positive number. Because it's 0, this tells me that we don't have any opportunity cost. We have maximized our profit subject to the constraints we have. There's nothing else we could do to make more money in this particular instance. Make sense? Okay. All right, so do we have any questions? So here's how we set it up. This was sheet 1. This is where our data were, right? And then we have our answer report, sensitivity report, and limits report, okay? All right, so do we have any questions about the process before we answer general questions? Okay. So was everybody able to get $44? and values of 6 and 2.
Yeah, Joe, I just can't see the screen anymore. I don't know why.
Okay, well, I'm recording it, so the video will be there for you. Okay, it's probably a bad connection. Jared, do you not have the screen on?
No, I do.
Can you see it? Because on my end, it shows that you don't see it. There we go.
Oh, okay. I wasn't looking.
So we're good. Okay. All right, so for this one, I'm going to stop recording, and this will be example number 1. Okay.